Okay, so now let's talk about efficiency in the labor market. So the figure is a similar one from the previous slide that shows the labor market is in equilibrium. We can see how it reaches the optimal level of employment and wage rate and how it maximizes producer and consumer surplus. So the firm's total revenue is the sum of the marginal value of all the workers that they hire, so all the way up to E star. Because the labor demand curve gives the value of the marginal product, the area under the demand curve equals the value of the total product. Because each worker is paid the wage rate and equilibrium, W star, the profits going to the firm is everything above that wage up to the demand curve, or the triangle P. Workers also gain, like I said before. Their gain is equal to the Q triangle, which is the difference between what they were willing to work for and what they're actually paid. In a competitive labor market equilibrium, we say that the outcome is Pareto efficient, because there is no way to make anyone better off without making someone else worse off. Here's what it means in the context of the labor market. An allocation is Pareto efficient if it's impossible to change the allocation to improve one person's situation, either a worker or an employer, so someone on either side of the equation, without hurting another party. In the labor market, this means that at the equilibrium wage, workers who are willing to work at that wage are hired, all of them. And firms that are willing to hire workers at that wage can find employees, again, for every position. In a competitive equilibrium, supply equals demand. Workers are paid the wage that they value their labor at, as represented by the supply curve, and they supply the exact amount of labor that they're willing to work for at that wage. Firms are hiring workers based on the value that they place on that labor, as represented by the demand curve, and they hire exactly the amount of labor that they want at that wage. Because supply equals demand, both parties, workers and firms, are satisfied. If we try to change the situation, let's say by raising wages or lowering wages, some workers who want to work at the new wage wouldn't be able to find a job, or some firms wouldn't be able to hire the amount of labor that they need at that wage. Any attempt to change the allocation would make one side worse off without benefiting the other, meaning that the labor market in equilibrium is Pareto efficient. So let's use that retail store example from before. At the equilibrium wage of $15 per hour, the store hires the exact number of workers that it needs. And the workers who want to work at $15 an hour are hired. If the wage were to increase to $18, the store might decide that they want to hire fewer workers instead. So some of those workers who wanted jobs at $15 an hour, now they're suddenly out of work. They're not going to be hired. They would end up being worse off, even though the other workers who did get a job at $18 an hour, they would end up benefiting at their expense. Now let's say the wage drops to $12. More workers might want jobs at the store, but the store would only be willing to hire a smaller number of workers than before because they need less labor at that wage. So some workers would be left without a job and be worse off. So the equilibrium wage of $15 an hour is in the labor market is Pareto efficient because any deviation would end up harming either workers or the store.